Hi, you're welcome to our Day 5 lecture. In today's lecture, we are looking at gradient boosting using XGBoost, an introduction to advanced machine learning techniques. Permit me as I take you through the lecture slides for today. If you're just joining from my YouTube channel, you're also welcome. Let's begin with the learning objectives. First, you need to understand the gradient boosting concept, how to train and tune an XGBoost model, how to visualize learning curves and feature importance, and lastly, how to save model for energy prediction dashboard. So these are the learning outcomes for today's lecture. Now, you need to understand gradient boosting concept. So first, the basic principle of gradient boosting, you need to recall that gradient boosting is a powerful method that combines multiple weak learners to create a strong predictive model through iterative improvements. How gradient boosting maximizes errors in prediction is by focusing on the mistakes of previous models and effectively reducing the residual errors, leading to a more accurate prediction in complex datasets. Key components that makes the gradient boosting effective, it's due to its reliance on decision tree, learning rates, and loss function to help refine prediction, enabling it to adapt effectively to different data patterns. Gradient boosting is a machine learning technique, like I said, that builds on a symbol of decision tree sequentially, where each new tree attempts to correct the errors made by the previous trees. The key terminology you should remember here are weak learner, ensemble, residual, and learning rates. Weak learner are models that perform slightly better than random guessing, while ensemble has to do with concatenation or combination of multiple models in order to improve the overall performance of the model. Now, residual is just the difference between the actual and the predicted value, whereas the learning rate is a scaling factor that controls how much each model affects the final prediction. I also want you to note that the value you have assigned to your learning rate is very important, because if you give a very high learning rate, it does not learn, rather it just cram doing training and actually makes the model run faster. But if you have a slow learning rate, it also takes time to compute. But it's necessary for you to give a more befitting learning rate by tweaking your model during training. Why choose XGBoost for machine learning? Now, one thing I want you to note is due to its high performance and speed in training models. XGBoost is said to offer exponential speed in training, which allows the model to be quick and efficiently to build within a stipulated time, which makes it favorite to ML scientists or engineers. Also, XGBoost is said to be able to handle missing value very well with its built-in strategies, and it has its capacity to manage missing data automatically, which helps to improve the model accuracy without significant preprocessing efforts, thus saving valuable time. Another reason is its robust regularization to prevent overfitting issues by using L1 and L2. And this helps us to reduce bias overfitting, leading to improved generalization on unseen data, which is very important for reliable predictions. How to install XGBoost? Now, there are step-by-step guide on how to install XGBoost, and you can access that through the official documentation as seen on the screen. So once you get started with XGBoost, you need to install the package using the following commands in your command terminal. Okay, so we have pip install XGBoost. This ensures a smooth setup. Next on our slide is loading data and prepare inputs. So we'll use the feature created in our day 3. So in case we are curious about what we mean by day 3, it's just the lecture we had on our third day class. So you could make reference to the lecture and also to the seminar, which contains the code. So we are going to use the feature we had in doing our coding section in this class. Also, from the screenshots from what we did the last time, we could see how we import pandas as PD, and then this time from XGBoost, we're imputing DMatrix. I'm going to explain what is DMatrix. And here we load our data sets, and from the last data after our feature engineering, which we named features.csv. And then the column, the date and the time column merged together as datetime. Okay, so with this, we are splitting the features and label, where we are dropping the column datetime, and the global active power, where the global active power is our Y, which we are calling here as the target. Here we create the D matrix for XGBoost. Now the question is, what is G matrix? So G matrix is just the XGBoost internal optimized data structure, which we use to store features and label efficiently for training. Considering cross-validation with XGBoost using XGBoost.cv function, this helps to avoid overfitting and give insight to the model generalization ability. So this is the code we use for cross-validation, and you can see the parameters. So in the parameters, we have the objective, where we have the regression as the task using squared error. And the maximum depth means we are set as 4. The learning rate is 0.1. The subsample is 0.8. The column sample by tree is 0.8. And we set our random seed as 42. Here is also our CV results for the XGB.cv. We assign that to the CV results variable, calling the parameter the D train, the number of boost rounds, the enfold, the matrix. That means we are working on regression tasks, and we are using the evaluation matrix, root mean square error. Early stopping, how much do you want to stop? As pandas through set seed 43. Now we are going to see more of this code during our seminar section. I just want to lay it out here and tell you what each parameters mean. So next, explain the parameters. The objective is just the type of task we want to carry out. Here we have the regression, squared errors, which is used for regression tasks. Then we have eta, which is the learning rate, the max depth, which is the maximum depth of trees, the subsample, which is a fraction of samples used per tree. Then we have the column sample by tree, fraction of the features used by tree. Now, for our output, it's going to print the CV underscore results.tail. This looks for the lowest test RMSE to select the best number of the posting round. How to fit and save your model effectively. You need to learn how to properly fit and save your XGBoost model for future use in our machine learning projects, or even in future. All you need to do is to fit the model, which is very important for optimal performance. And once fitted, you can save your model to reuse it without retraining. How do we go about this? All we need to do is assign this to the variable best round, where our CV underscore results will be the test RMS is mean dot IDX mean. And then we have this other parameters. Now I want to recall that we also use the job lib to serialize our model for later use, which means we use it for loading or for saving the model. And all we need to do is to import job name, and then we write this few code, and you could see here the saving formats will be model.pkl. So this will help us save the model after training. And we can also use the save model doing our doing our GUI deployments. So understanding XGBoost results visualization. Here we need to explore how to interpret and utilize visualization to enhance the model comprehension and performance analysis for machine learning. I want you to note that visualization are crucial in understanding the model performance, which help in identifying the patterns and also enhance our machine learning models for better prediction. Now we are using the matplotlib libraries to carry out this visualization task, where in this XGB.plot_importance, where we have the final model, the maximum number of features we want to see, and then set the height as 0.5. Here we are adding the title where we are calling it as top 10 features important XGBoost, and we are tightening the layout in order to keep the image within a fixed region. And then plt.show displays the plots. Another one we have here is the plot learning curve. So this helps us to plot our learning curve, where we have the CV_results with this parameter in there. Then we dot plot and we set the figure size to be 10/4. Adding the title called the XGBoost learning curve, the x-axis where we call that plt.x label boosting stand, that's the text you will see when plotting. And for the y-axis, we are assigning that to RMSA. Then we set the grid to be true if you want to see the grid. If you don't want, you just remove it or set it as false. And then we put the plt.tight_layers, and plt is used to show the results. That means the plot. So thank you for listening. So watch out my next video on how you can go about the coding section for today's class. Okay, so if you're just joining us for the first time, don't forget to subscribe, like, share with a friend, and hit the notification bell so that you get notified when I release my new video. Thank you for watching. I'll be signing off now. Bye.